nowhere in there to say anything about Rolle's theorem, but right there should kind of be a dead giveaway. You're looking for a derivative that equals 0 at some point in between a given interval. All right, so without saying, hey, you've got to use Rolle's theorem, this is where you've got to learn to interpret the directions, see what they're doing, and see if you can apply a theorem to it. All right, so you're going to have an extra step because they're not giving you the interval. All they're going to give you is a function. All right, so like x squared minus 3x, maybe say plus 2. It's a parabola, right? So no, I don't have to go through a verify step or anything, but should I note that the fact that this is continuous, all right, it's continuous and it's differentiable because it's a polynomial curve. All right, so yeah, I mean, I'm setting this up because obviously it's in the section, but we know those are your two things that you're going to check. Now, I can't check to see if it's continuous on a closed or an open, or differentiable on a closed or open, because I'm not given an interval yet. All right, however, it's continuous everywhere on its entire domain. It's differentiable everywhere on its entire domain. Okay, so first step on this one, I got to find those x-intercepts. All right, so find x-intercepts. All right, how do we find x-intercepts? We basically solve the equation, right? So we're going to take that polynomial curve and set it equal to 0 so that we can solve it. All right, we're going to solve by factoring. Okay, so let's see, it'll be an x and an x. 2 times 1 is the only thing I got. To get the 3 in the middle, they both got to be minus. All right, so then this one I've got an x equals 1. On this one I've got an x equals 2. All right, so my interval is going to be from 1 to 2. Okay, because those are my x-intercepts. This is the x-intercept of 1, 0. This is the x-intercept of 2, 0. It's in between 1 and 2. All right, so my interval that I'm going to deal with is from 1 to 2. Okay? And there again, even though it doesn't say Rolle's theorem, I've got my interval now. Okay? It's still continuous on the closed and differentiable on the open because that's what this polynomial curve is. All right? I don't really have to do a verify thing because they're not focused on the theorem. So what I'm going to do now, though, is I've got to calculate f of a and f of b. So let's calculate f of 1. All right, again, hopefully we can do this in our head. 1 minus 3 and then plus 2. That's going to equal 0. All right, let's plug in our f of, what was the other value? 2. All right, this one might be a little bit more work. 4 minus 6 is negative 2 plus 2. That one equals 0, 2. All right, so that's good. My f of b does equal f of a. So f of 1 does equal f of 2. Okay, so that's good. All right, now what do I have to do? I just now have to show that my derivative equals 0 at some point in here. Okay, so I'm going to now find my values of c. So even though I'm not doing the theorem and everything, I'm still doing the same steps of. First thing we do is calculate that derivative. Should be a straightforward derivative, so 2x minus 3. Ooh, that was really easy. 2x minus 3 because it's a polynomial curve. Set it equal to 0, and notice when I calculate the derivative, that's on a line by itself. All right, and then I come down below it and I set it equal to 0. All right, we do not want to string this all together. You don't want to do f prime of x is equal to 2x minus 3 is equal to 0. We don't put two equal signs in the same equation. Okay, so 2x equals 3, x equals 3 halves. So math's not too hard there. All right, this really isn't any type of theorem or anything like that. You could write a therefore statement, but we really don't need to. All right, it says show that at some point in between that. Now let's write a therefore statement. Therefore, since, let's go back to c. c equals 3 halves is in the open interval from 1 to 2. And f prime of 3 halves equals 0. Then this one was find it's in between the x-intercepts, so let's say then c equals 3 halves lies in between the x-intercepts.